Hi everyone. Today we're going to learn how to use FTool. So just wanted to make a quick video on how to use it and what are the type of things we can get out of it and what type of tricks we can learn. So here is FTool. The model we're going to be doing today is this one. So it's a 2D frame with a pin support and a roller support, and we're going to look into this and do some small variations to see if the results change a lot or not. So the first thing to have in mind is this menu here on the top. So file menu is about opening, saving, and exporting. Usually I don't export using this. I use the snip tool, but I'll show you that in a little bit. The options menu is very important. It can help you decide the sizes you want for your model. So usually I keep everything in large because it's a lot easier to read. So let's do that. Then also we have this units and number formatting. This is very important, especially to set up in your problem before you start solving. So here is a really big menu with all the units. So you can keep them in SI units that you can see here. You can transform them into kilonewton and meter. Then even your section sizes go to meters, or you can change them to US units if you so want, foot, inches, and stuff like that. So I'm going to go to SI, and I'm going to, maybe not, I'm going to move it into kilonewton and meter, and I'm going to make sure everything is in decimals. So if you need more decimal points, for example, here for the force, you can add a couple of X's and something like that. So springs, we're not going to be using them, but we can set up like this, and that looks good to start. So here in display, we can set up, for example, a black background if you prefer, and then this other stuff will be more important once we have results. So the first thing you need to understand in FTool is there's lots of icons around this main screen. Usually we start with this one here. So this one here is something like a display menu. So you can zoom in, you can zoom out, and you can fit the world on screen. This is a very useful button, or you can refresh your display. Here you have your geometry menu. So here is where you can actually put on the nodes and the bars for your structure. And then here you do your modeling parameters. So here is where you define your material. Here is where you define your section. Here supports and then loads and stuff like that. Here on this right side, you have the menu for results. So axial force, shear force, bending moment, and deformation. Now here on this right side is a different menu that shows up for depending on where you press. So depending on where you press, this menu changes. So this is where you actually define the stuff in this menu. Okay, so let's start putting this structure into FTool. So if we first decide that node 1 is on position 0, 0, we can go here. There's this button here that's called keyboard mode. So if you do keyboard mode for the nodes, it's a lot easier because you can put the nodes straight away with a keyboard. If you don't have this on, then you have to put them with a cursor. So it's quite hard to find where you want to put the nodes. So I'm gonna turn the keyboard mode, turn on the nodes, and put the first one in 0, 0. Okay, so this is 0, 0 in our model. This node shows up here. So now we can put all the other nodes. So if this is 0, 0, then we need to go 5 up in Y, then we need to go 3 up in X, then 3 more up in X, and then 3 down in Y. So if we start at 0, 0, we go up 5, we get 0, 5. Then we're going to move 3 to the right, we get 3 and 5, then 6 and 5. And then to move 2 down, we need to go to 6 and 2. So this should be the 5 nodes I need. They kind of look okay. And then you can press here the little fit world to screen, so then you can see the entire model. It fits into this. Okay, so now let's do bars. So if you press insert member, with the keyboard mode on, you need to redo all the nodes, which takes a little bit of time. So the easiest option is cancel. Press the keyboard mode to be off, and then you can press the insert member, and then you can use your mouse to just connect everything. Okay, press here, and then you're done. Okay, so that concludes the geometry. Once you get to this, you can, I guess, if you want to show what are the sizes, you can do it with this, but it's not necessary. It doesn't change the results, so I'm not going to do it here. Just going to delete and delete. Okay, you also have this button here that does transformations. So if you make a mistake in your model and you want to move it, you can move, rotate, scale, and mirror your model. Although, since this is a simple software, I always recommend if you make a mistake, you can start from the beginning because it doesn't take too long to redo. If your model is complex, then you can also use this move, rotate, and scale options. All right, so now we have our structure done. So now we can play, for example, with the material, and we can start inserting the material properties. So the first button here is called Create New Material Parameter. So if you press here, we're gonna open a different box that tells us what's gonna be the name of the material and then the type of the material. The name doesn't really matter. So you can write here steel, you can write concrete, but it's not the name that makes it that specific material. So you can actually just type any random stuff for your label, and then you can make, let's say, steel isotropic, concrete isotropic. There's a couple of predefined options. So if you press steel isotropic, here already shows what would be the Young's modulus for steel. But if you want, you can get, let's say, a different name for, let's say, concrete. You press done, and here is the properties already for concrete. Since I don't want to use any of them, I'm going to delete these two. So I can press here, remove material parameters from list, and I want to delete this one as well. I'm going to start a new one. I'm just going to call it general isotropic. So then I can put the properties that I want. I can say, for example, I want this to be 1 or 100 or whatever I want. And since for this model it doesn't really matter, I'm going to keep, let's say, 500. Any number here is fine. And I'm going to press all to apply current material to all members. Okay? So once you press that, you should get these bars to be with this material. So you're done with the material properties. You can move on to section properties. And here the menu looks kind of the same. So you have here the create new section properties. You can press it. And there's lots and lots of options for different sections. You can check like welded eye shapes. Let's put a name to it. So you can open here and you can find different shapes for I-beams. Again, I'm going to delete. The only thing I need is any random shape. So I'm going to use a circle, for example, because with a circle, again, I need a name. Because with a circle, I can put, let's say, this to be 100 meters. But it's quite a big circle, maybe 0.2 meters. Although it doesn't really matter the numbers I put here. And the circle is defined just by one variable. So it's a little bit faster. So I press all. And now, oops, I press here, all. And now all my bars have this section as their section. Okay, so I'm done with that. Then I'm going to do supports, which is the next button in line. And here we get fix, 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 or free, free, free for displacements in X, Y, and Z. Then you can do pre-described displacements and rotations. So if you do supports that are sinking or something, you can do it here. Or you can do elastic supports with springs. In this case, the only thing I need is a pin support and then a roller support. So to do pinned, I'm going to do fix and fix, and then select the node, and then press this button here that says apply support conditions to selected nodes. And here it shows already the drawing that I'm looking for. So then I'm going to make free in X and fix in Y. So then I get my roller support in this point. If you want a fixed support, you can just put fix, 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 and you get a fixed support like this. Okay, so select and apply. Okay, so I'm done with the supports. This is for hinges. We're not going to use hinges in this problem, but that's how you can do it in FTool. And this is for rigid bodies and more complicated types of elements that you can also have in FTool. But for now, we're going to keep them as normal bars. So what's missing? Next step is the loads. So we have a load of 6 and a load of 24. So for this, we're going to go into this menu, nodal forces. Same stuff. I press this button here to create something new. The name doesn't really matter. We press done. And now if I want to apply something in X, I'm going to put the 6 to be in f of X. Then I select the nodes and apply here. And here is my load of 6. That looks pretty good. If I wanted to point it to the left, I put -6, and then it would go to the other direction. Okay, now that I want to do a load here, I need to create a new load. So if I go to this one and I change this to 24, then that load changes as well. So I need to create a new load. Let's put it as this correctly. And now create another load, call it something, press done, and I'm going to put 24. And you'll see once I apply here, the 24 is actually in the wrong direction. So if I want to push it down, I just put a minus, and here I get my 24. Let me zoom out a bit, and this looks pretty good. Again, if I want to get rid of this 0.00, I can go into units and formatting, and for example, here where it says force, I can put just 1 decimal point or even 0, and here we go. Might be a bit easier to read. Okay, so what's missing is the UDL, so I can go and select these two bars. So either you can select with a box like this, or you can press Shift, and you can select the two bars. But basically, now this button here is the one that does the loads, so we can create a new one, call it something, press Done, and now we want in the global direction 24, no, we want 3 to be applied in Y, so -3, and apply here. Okay, so this looks pretty good. I'm very happy with this. This looks exactly like what I have to do. So I can now press, for example, here to start getting results. The first thing you're going to see is FTool always asks to save your model, so you can keep it in the desktop. In this case, I'm going to delete the file afterwards, so I don't need it. If you want to use it in the future, keep it in a folder, name it properly, so then you can use it more often. So the first set of results you see here, now that I saved it, is the axial force. So here you can see the compression in the columns, while here is the shear force diagram. So here you can see the shear force in the columns and also the shear force in the beam, while this one gives you the bending moment diagrams in one go. The last result is for deformation. So this would be the deformation of your structure in this case. So you can decide which results you want to see and how well you want to see them. There is this bar here that changes the scale of the results. So sometimes they're kind of hard to see, so you can tweak them a bit, or here the bending moment, for example, if you want to see them a little bit better. As you can see, this one here is parabolic because there's a UDL, but if you keep it, let's say like this, it might be harder to see it's parabolic in the results, okay? So up to you how you want to get this to be shown. So that concludes how to put the structure and how to look into it. Another useful thing is when you are in the results menu, if you want to find, let's say, the value at certain distances, you can click on it with the left button, and it shows you the values of the diagram in other positions. But let's say you want a very, very specific position. Let's say x equals 2.5. You want here in the middle, and you don't want to be pressing, zooming in and trying to press to get the 2.5 exactly. So what you can do is you can right click on the bar, and here on the right side, the results menu is going to show up. And you have here this button that says step. So I know my beam is 5 meters. If I show in a step of 1 and I press enter, and now I do the right click, I'm going to get the results for every meter. So I get 6, then 12, then 18. So if I need that 2.5, I just need to change the step, let's say to 0.5 or to even 2.5. Right click, and here you can read the results are 15, okay? Which is a lot easier than pressing here, okay? So once you change the step, actually, you can then press it straight away. So it's a little bit easier. Didn't know that. So I'm learning while I teach you how to use FTool. So if you change the step here, then the right click becomes a little bit easier. So that's already a little bit better because it helps you click it. Now, what other stuff can we look now in the display? You can change it back to white background if you want, if you so prefer. Black background is better for me when I work. If I want to show results, I usually go for white background. And then, if I want to get the results into a Word document, I get the snipping tool from Word, and I can just use it to press new here to snip the results. And then this image I can just copy and paste it into Word if I need to write a report about this. Okay, so let's go back into black and see what other buttons we have here. So we have orientation of the members. If you so want to look into it, we can make the supports disappear, but I prefer when they're there. We can have loading with results, so you can have the loads with the results on top. Load values, yes or no, up to you. I'm gonna make them disappear. I prefer like this. We can have the steps values. Again, these numbers here would be influenced by this step that you have here. So for example, if I make it 0.10, probably this becomes very unreadable, but it is possible. If I make, let's say, 1, probably it's still decent to read the numbers. But usually I also don't have this on. So let's make it disappear. Transversal moments, okay, just helps you with the readability of your diagram. Bending moment sign, you can keep it on or off, so if it's negative or positive. In this case, they're all positive, so it doesn't make a difference. And you can have the reaction values, so if you need the reactions, you can toggle them here. Node numbers, 1, 2, 3, and 4. In this case, they're a little bit different. And member numbers 1, 2, 3, and 4. Again, if this is important, you can show it or not. Now that you're done with the model, you should definitely play a little bit with it. So if you look at the bending moment diagrams, this is the numbers we get. So we should have tension on the right on here, and then tension below here. And this bar shouldn't have any bending. If you go to the deflection, you can see that straight away. So tension on the right in this bar, and then tension below in this bar. And this bar is not bending, it stays flat. So what happens now, for example, if we take this support and we make it a pin support, so fixed. So now you can see the deflection. Let's save it. You can see the deflection necessarily changes, right? Just because that point cannot move. So now we have tension on the right. Then this is a little bit of a strange one. It's tension on the top and then it goes below. And here we have tension on the left. So if you have a look into the moments, now that's exactly what we see. Tension on the left on this side, tension on the right, and here we get tension on the top and then bottom. Let's zoom in again. And if you guys see, there's a little bit of tension on the top, right, bending down. Then this stays sagging, so happy beam. And here, a little bit of tension on the top as well. This is necessary to make sure this angle stays 90 degrees. So let's try another model. Let's say, for example, we do the same thing, but now with fixed supports everywhere. Okay. So if we see now the deflection, we're going to get something, a little bit more complicated. Let's have a look. Let's make it bigger. But now we can see there is tension on the right, then tension on the left, and here tension on the top, then bottom, then top, and here tension on the right, and then it has to go tension on the left to close down. If you go to the moments, that's exactly what you see. Right and left, then up, up, and then right, and then left. So once you build your model, my suggestion for you is always to play a little bit with it. So another thing you can do is to change the material properties. So if you focus, for example, here we have 1791. If we go here to the material properties and we need to press here, and let's say we add a couple of zeros to the material properties, apply to all, you will see that you still get the same answer here. So I think this kind of covers everything about FTool. It's a beautiful software for how simple it is. So it's really good for students. If you guys want to experiment with your structures, this is the best software to try it out. And it's also pretty good to teach. So I want to thank Luis Fernando Marta for making this available for everyone. I've been using this since I'm an undergraduate. Now I teach, and I still use this for my teaching. So thank you very much for making this available for everyone. It's super good, and I really like it. So I hope you guys like it too. I hope this was a good video and you can use FTool for your own projects. And I hope you enjoyed it and have a fantastic day.